So today I'm going to talk on Hashicorp Packer, and Packer is one of the open source tool developed by Hashicorp. If you already familiar with Terraform, which is also an open source tool for infrastructure as a code, then this tool is also similar. But the purpose of this tool is a little bit different because this tool serves as a image as a code, and this tool is specifically used to deploy the image and deploy your customized image and provision your software, and you can deploy it on any of your cloud platform or on your private cloud or VMware or anything that you want to do. So just 1 second. So let's first discuss what is Packer, and then we will do a quick demo so that we will see how Packer works, right? I don't know, next slide is not going through. What is happening? Okay, so what is Packer? As I said, Packer can be simply referred as a machine image as a code. So this is not a infrastructure as a code. Terraform is an infrastructure as a code, but Packer is a machine image as a code. Packer is an open source lightweight automation tool, and which is used to create the machine image, as I said. Um, so Packer is basically lets you create identical machine image for multiple platforms from a single source of configurations. It support all the major operating system like Windows, Linux, Ubuntu, right, on multiple platform in parallel, right? And why Packer is needed? Because Packer is it solves a common problem in IT infrastructure, which is basically to create your image. If you traditionally creating your image, how do you create it? You basically log into your console, and then you create your VMs, and then put all the software onto that, vulnerabilities, agents, everything on that, and then from that you will do your customization. So that makes your job very tedious and time consuming. So Packer solves all this problem with a code. So it supports all your public cloud and on-prem. And Packer can also be used in conjunction with your configuration management software like Ansible, Chef, and Puppet. And it can also be embedded with the CI/CD pipeline as well. Okay, so advantage of using Packer, super fast infrastructure deployment. Means Packer image allow you to launch completely provisioned and configured machine in a seconds, not just a minute. In a seconds you can provision your image. So this is because Packer creates identical image for multiple platforms. So multiple provider portability is also there, right? It improved the stability because Packer installs and configures all the software for a machine at the time of image that we built, and this basically ensure that your image are consistent and reliable, that you will always work the same way regardless of when or where they are deployed. Greater testability, which means Packer image can be easily tested in a variety of environment, right? Which helps you to ensure that they are stable and they are reliable. So you can test your image in different cloud provider like in AWS, in Azure, or even on your on-prem. Okay, so next slide. So Packer terminology, if you want to understand the Packer terminology, then these three components, works under the hood. The first is template. What is template? Template is nothing. Template is your overall configuration file, right? So builders in Packer are components that creates machine image for a single platform, and these configuration file can be written in JSON or can be written in a Hashicorp language as well. Most of the time, I've seen that people use JSON, but as of now, I think Terraform Hashicorp has already released SCL2, which is a similar format or similar the format that you use with the Terraform configuration, which is basically help you to easily read the configurations. So you can use either JSON, or you can use the SCL2. Okay, so what is builders? So builders in Packers are component that basically creates your image. This particular things is responsible for creating the image. Okay. So builders read in some configuration and use that to run and generate a machine image. A builder is involved as a part of build in order to create the actual resulting image. So some of the most popular builder in the Packers are Amazon Web Service Builder, right? Azure Builder, Docker Builder, Google Cloud Builder, VMware Builder. So for every cloud platform, the builder will be different. I will show you when we cover the demo how the builders change. Now, provisioners are basically you install or configure a software on top of your machine image, right? So once you have specified the builders, Packer will create the machine image according to the configuration, and the machine image will be stored in the location that you specify. So you can install software, you can do anything that you want to do on top of that of your image. So these three components are the building block of Packers, right? The template, builders, and provisional. You can alternately use the variables, but I'm not going to cover this in this demo. So this is the sample templates of the Packer for GCP. So this entire configuration is called as a template, right? And within the template you have builders, you have a provisioners. So as I said, builders, the type is Google Compute. As I said, this is for this as we are going to target our Google Cloud platform. So the type of this builder would be Google Compute. If this is AWS, the type has to be different. The account file is the file that we use to authenticate, which is basically a service account. And the project ID, the source image, it is BLI, basically the baseline image. You can take any baseline image, and on top of that you can customize it. And the again, these are the arguments. They are basically builders is a list of arrays, right? Sorry, builder is an array of your JSONs, key and values pair, where you can put multiple arguments. And then we have a provisioner where I'm doing nothing. I'm just copying the file. The source is demo file.log. I'm copying into the destination. And what would be my destination? The image, right? So I'll cover this configuration file in the demo. We have a separate configuration file. Okay, running a Packer build. It's build. What are the available commands that you can run? Packer build. When you run Packer build, it is basically used to create your image. Then we have a different types of command like console, fix, inspect, validate. Validate is something that you check your configurations. And Packer version, if you type Packer version, it prints the Packer version. And there are different command that will be used for the different purpose. So how to create a custom image in GCP? These are some steps that you need to follow. And the first step is that obviously you will create a service account with some appropriate roles. And then we will write our JSON file, our template in JSON format to create the Linux image. Similarly, if you want to create a Windows image, and then we will run a Packer validate command to validate that our template, our configuration is fine. And then we run the Packer build to create the image. Once your image is created, then what you're gonna do? We gonna create a new VM from that custom image, and then we will do SSH test or verify it in the either way. Next slide is Packer in action demo, and this is the overall architecture, or you would say the how Packer target to the cloud platform or any platform. So you install Packer on your local machine, and then you write your code like in JSON and plus your baseline image. You can write in SCL2 as well, but we will write in the form of JSON. And then we will target this template to our Google Cloud provider. So once you build this template, what is happening behind the scene? It will create a temporary compute instance on Google Cloud, and once this Google Cloud is up, once this VM is up and running, it will create a new image from this VM, right? And then this VM is gonna terminated. So that's why it's a temporary compute instance. So we'll see this in live here, how this Packer works. So here is my
my increase the size a bit. I mean, can you zoom in a bit? Zoom out actually. Zoom in.
1 second. Can I zoom this? Okay, this one. Control. Oh, it's a zoom out.
That's zoom out.
Sorry.
That's you need to zoom. So control plus again.
Now, is it visible?
Yeah, one more time will work better.
Okay. Fine.
Yes. Thank you.
Okay. So this is the the configuration file. We can also call it template, and the name of this this template is the image apache.json. I named it this. So in the builder, so in this directory, close all this. So this is the one. In the builder, I have the type is Google Compute, because I'm going to deploy the image on my Google Cloud. This is my service account. This is my service account file, right? And that is my project ID. The source image, I have taken this one. This is my source image of Debian. The username has to be Packer, or you can choose anything if you want. The zone is Asia South 2A, which is I think Delhi. Again on provisioner, so basically this builder is going to take this image and deploy this image, and on top of that I'm going to install an Apache server, and this is what I'm going to print when I hit the URL. So before that, let me show you my Google Cloud Console. So let me show you my service account first, because this is important, because you need to have an appropriate roles attached. Okay, so this is my service account, and the role you can see compute
So
admin.
you can increase the size here as well.
Okay.
Use control plus.
Let me know if you can see. Is
yes,
it okay?
Better than earlier. One more time will be better. That is better. Okay.
Better? Okay. So this is my service account that I have used. This is my service account key file, right? And what is the role? You can see compute admin and the service account user. This role is very important. If you don't attach this role, your Packer is not going to authenticate and deploy the image. So this is must. Make sure that. So I've already downloaded the key file, JSON key file, which is this, and I put it here, the path. Project ID, this is my project ID, which is I'm going to target, and again source all this. Provisioner, as in the shell, I'm going to execute some commands. So let's deploy it. The first command that is going to check is validate. Okay, sorry, I forgot to tell you how to install Packer, right? So how to do that? The first step is like go to Packer download. Yeah, this one. So go here, Windows, and just you can download it. The download is very simple. Just a simple exe file. You can extract and install it. That's it. Nothing, no rocket science here. And once the Packer has been installed, what are you gonna do? You're gonna just check the version. Right, this is your Packer version. Now check here. Now validate your configuration. Packer validate, and you need to enter your, the template name here. Image. Oh, 1 second. Give me a second. So let's type it again. Validate. So this is my file. Image. Configuration is valid, right? So let's build it. You can see that this is going to trigger and checking the image, if this image is already exist or not. So it's creating an instance. See here. See, this image is creating, right? This is a temporary VM. Okay. The VM is created. Now it is waiting for SSH. We'll take this one. So now it is going to trigger your provisioner. Your image is ready. Your VM is ready. Now it is going to trigger your provisioner, and going to install this Apache web server. So
which means that the user has the privilege to run those shell script or the commands on the VM, and once that is done, then it is going to create an image out of that VM, right?
Right.
That's how you come up with the custom image.
Yes. So it takes a few seconds more. So you can imagine that how fast it is, right? So if you do this with your manual with GUI, then how much efforts that you put, right? But here you just write the code and everything is ready.
Is it only for creating the custom images, or what are the other use cases we use Packer?
Right now, Hashicorp focus this tool on creating the custom image, but I heard that Hashicorp is putting a lot more feature into it to do additional configuration, like just like those Ansible and Chef do that. But I don't know if these features have been already embedded. But as of now, this tool is specifically focused on image as a code. That's it.
Okay. And once this image is created, it can be ported to any platform, or it is based on, like as you are saying here, only for GCP. So here, this is going to be created specifically for GCP only.
Yeah, because we have taken the baseline image from the GCP, so this is going to be stored in the GCP only. But if let's suppose if we have any other platform, let's say on-prem or VMware, so I can store those images on my local machine as well, or somewhere else, like on somewhere, and I can use this image to deploy it anywhere if the cloud provider or that platform supports. I haven't tested it in production, but maybe next time I'll come up with this demo.
Okay.
So you can see that, yeah.
So instance is now deleted. Now it's going to create an image out of it.
Yeah, so it is deleting your instance now because the purpose has been done, and it is now creating your image.
So image will be created on the GCP platform itself, right?
Yes, okay. Yes, yeah. So you can see that this, where is this Packer name? This image has been created with the name Packer and with some random number. Oh, sorry. So this custom image has been created. The location is Asia. Size, the disk size, everything is there. Now what we are going to do, we are going to create a VM from this image just to test. Like,
so before that, I mean, whatever steps that we have performed, so Packer has nothing else to do here. It is only helping us to create a custom image on the platform where you are working. It is not going to download on your system or add any volume to your operating system, I mean the local system, right?
I mean, the feature is there, but you cannot download it from your, from your Google or cloud platform image. But
Mhm.
I think the feature is there, but I haven't used it. Maybe I will explore and then I'll come up with for any comment on that. So it was in Asia South, right?
And can I port my VMs, the custom VM that you have created, to other zones or the other region?
Can you what? Say again?
Okay, so the VM that you have created that was meant for US, I mean Asia South 2,
Right, right,
right? That is for Delhi zone.
right.
Can I use that custom image to create the VM in other zone or the region?
Yes, yes. Actually, the baseline image, because we have taken a baseline image,
Mhm.
this one, from that region only, from the Asia region only, right?
From the
So
zone.
yeah, from the region actually.
Okay.
I think image is a regional kind of
Yeah. Yeah.
file.
Resource.
Yeah, yeah, resource. So if you take it from the region, it will you can distribute it to the any zone. So I've taken this image from the Asia region only, and on top of that, I am doing my customization.
Okay.
You can move once your image is created. You can move it. I think there is a feature from Google Cloud that you can move your image by taking a snapshot and
Yeah.
then move it to the another region, right?
Yeah. Okay.
Okay, so I'm going to create a VM on my customized image. So here you need to change your image. So this is my image, right? I'm going to select it. Allow us HTTP traffic because Apache web server is running. We need to access on port ID.
Does it also reduce the cost of monthly cost also somehow? I mean, today I was trying out this one VM. Okay, that was for Mumbai June. Okay,
Mhm.
but for this almost same configuration, it was charging around $38.
No, I don't think that that it will minimize the cost because the cost has to be the same. The cost is on your operating system and your instance size. The
Okay.
only thing that Packer is going to help your reduce your efforts and making it to manage your image better.
Okay.
So my VM has been created from this customized image, and let me check. Yes. So this is what we have put right in my customized image. I put this, I install the Apache server and then I, customize this with some statement like hello world, I'm a customized image on the cloud. So this is what it is printing, right?
Yes.
So this is what all about Packer. And since Terraform is adding, the Hashicorp is adding a lot more feature into it, which will help us in future, which will help us to explore more things with the Packer. So let's tune in on it.
Yeah.
Thank you.
So that's all right.
Yeah.
Okay. Thanks so much for presenting that, and this is really helpful. So far, even I did not have the real understanding of Pepper. I was thinking that it is more of uh, yes, it is more of related to the Terraform, but I was not aware what the specific use case can be. So
Yeah.
now I have that clarity. Um, Also, just want to understand. So, if someone needs to know about Pepper, they can reach out to you further, right?
Yeah. Yeah. Definitely. Yes. Yes.
Okay, thanks. Okay, so
I
anyone
already
else has any
stopped
question?
sharing. Do I need to stop the recording, right?
No, you don't have to. I will take care of it. Let's have some questions also included as part of the recording.
Okay. Yeah.
Yeah. So, anyone has any questions, if you can share the presentation also.
I have a doubt beyond Packer. So over here, by what I understood is we are under a cloud platform lock, right? Because we are not sure if we can move images from one cloud to another when we create that image. So instead of doing that, why won't I go ahead and download a cloud image from the provider itself, like from Ubuntu or Fedora or Debian, work on that and use that across clouds? won't that be a better option and more manageable option when I'm working across multi-clouds in an organization instead of using Packer?
I don't think that cross images can be used in in cross platform. Let's say if you take an image, baseline image from Google, and you want to customize it and deploy it into the AWS, that is not going to be feasible, as per my understanding.
I'm not
Which
talking
is,
about the cloud
yeah,
images.
yeah.
I'm over here. I'm referring to the images
Can you
that.
bring the presentation on the screen?
Okay, share my screen.
Yes.
I'm
Okay,
referring here to the images that providers themselves provide, like Ubuntu provides cloud images, right? Then Fedora provides cloud images.
Yeah,
Debian.
yes.
I'm
Yeah.
referring to those images. Can't those images be used across cloud?
That is possible. Yeah, that is feasible. That's what I wanted to say. If you have your customized image, you can download it on your local machine, and you can customize on top of it, and then you can deploy it on any of the cloud platforms they supports.
So can
Right?
Packer be leveraged for that? Like, can Packer take that image build and push across clouds?
Yes, absolutely.
Okay.
I believe there could be this the concern with the compatibility if you are not providing the right set of cloud
That's what
provider.
what I'm saying. If the compatibility matches, then you can take your customized image and deploy it onto your Google Cloud. Things happen, right? When you migrate from on-prem to Google Cloud, you take your traditional customized image and then you put it onto the Google Cloud or AWS Cloud. So things are happening. So Packer also doing the same way.
How the configuration and the metadata is aligning with the individual cloud, that may differ as is. So in that scenario, if you have an option to actually take a base image and whichever cloud platform you want to create the custom images, I think this can be a much better use case. Better way to deploy.
Yeah, Jitendra, let me tell you the real use case here. When let's say your organization is fully operating on on one cloud, Google Cloud, right? And you have thousands of services are running. For thousands of services, I'm sure there are thousands of BLI images, right? There are thousands of images as well, right? So how do you manage those thousand images every quarter or every month when you patches, when you do some patches or release some patches on top of that? So things becomes tedious when you do it manually. Packers solves your problem here. You can do thousands of image parallelly if you want to, right?
Yes,
So that makes your life easy.
certainly. Okay. Any further questions before we conclude this presentation?
Yeah, just to add on in this topic, so Sumit rightly said that suppose infrastructure as a code, like we are provisioning the infrastructure, but Packer, like whatever the in the organization, we are using number of images, number of custom images which we are deploying in our target environment. But in that particular image, manually, if we'll do something changes or deployment, so that will be very difficult to manage your thousand of images to deploy, right? So
Right.
Packer will come into the picture so that automatically thing will be happen on the backend, right? Whatever the changes is required, whatever the page need to update in the thousand of images, so that will be taken care by our Packer. So that Packer come into the picture to the thing can be automated, how image will customized, how image something new features is coming, how to integrate it with every image. So that Packer will help out here, right? So this is
Right.
the practical things.
Right. And I want to
Uh,
add here. Um, this is a very simple demo, right? This is a very simple image. I just install the Apache web server. Imagine if you have 10 applications or 10 new agents, more vulnerabilities you are adding, right? Releases are adding to your images, so things will become complex. So there Packer will solve your problem, because you have everything you have stored in your repository, the software part, the agent and everything, and you can pull it on your local machine and deploy it onto your target platform easily.
Yeah, and
yeah,
if I can add more again, so think of you want to automate your VMs, whatever you're going to create on either of the cloud platform. So you can actually induce that automation script into using these custom images, right? You can have the start and stop script embedded into it. Whenever it is going to execute, it will ensure that those scripts are running whenever you
Yeah.
start the machine, whenever you stop it. So that also makes it easy to maintain otherwise.
Yep. Yes. Agree.
Okay. Fine. So this is really a great presentation. Thanks, Sumit, again for sharing it. Okay, so
Thank you.
we'll end it here. Thank you.